Hello, this is Mike. Welcome back to Alarm Engine Academy. In today's video, we're going to be talking about the alarm engine architecture. And basically, it's going to be a high-level overview of how the pieces of the alarm engine fit together. We won't get into specifics or details on actually how to connect them or how to configure them. This is more of just a review using our design guide as a reference point, but I want to kind of talk through some of the terminology and some of the different things that you're going to hear during this training session over this series of videos. And it may help you understand exactly what we're meaning when we're talking about inputs, outputs, and things of that nature. So, alrighty. So first of all, we're going to start off with the inputs side of the system here. So if we zoom in here to where we can kind of take a look. So in the alarm engine architecture, we refer to inputs as pretty much anything that can create a information into the system. So this can be, that gives us feedback. So you have your hardwired inputs and your wireless inputs are the two major components of that. So the main board has 16 inputs on it. Then you have your XIN module that has another 16 inputs. You can have up to 128 total inputs into the system. And now those total 128 inputs include your wireless and your hardwired inputs. And so again, these inputs can basically be any type of detector that you would like, that we are compatible with. But that's what we're going to be referring to when we say inputs. We're talking about the hard physical item that is giving us feedback, whether that's a wireless device or a hardwired device. So next I want to talk about outputs. So if we move over to this side of the board here, so our outputs are mainly contained on the main board on this side, but we also have some expansion modules that you can consider as well. We have the ELK M1RB board, which can be used on the E27 as well by utilizing the programmable outputs jumpers. So you can use that there. And then we also have our XOU, which is our expansion module that can go onto the system's bus. You can have up to 32 total outputs on the system. So again, outputs are things that the system is triggering, or activating, so that they can trigger either an additional action or they can, we control the action. And one of those types of things would be our alarm outputs. So our alarm outputs tie into the main board, and you have an alarm output 1, alarm output 2. And so those come pre-programmed as speaker outputs, but they could be configured to be voltage outputs as well if you're using a different type of thing. But again, we'll get into that in the configuration and setup, but I'm just really touching on the type of terminology. So outputs is what we're referring to, relays, alarm outputs, things of that nature. So the next thing I wanted to refer to was our user interfaces. So obviously the most common user interface is going to be the LCD keypad. So that would be the local interface for the customer. You could also utilize one of our touch screens. So you could use the 7TS touchscreen. It would be another user interface. And we don't necessarily show it here on the design guide, but our mobile app is another interface we would refer to as the user interface or the installer interface. And then there also could be some third-party integrations that could be a user interface into us as well. If you're using a Control4 or Savant, that touchscreen or that their app may be the interface that the client, primarily looks at. So these are user interfaces. So when we're referring to that, that's what we're talking about is things that allows the customer to interface with the system. So next we want to move on to the communication side of things. So our primary form of communication with the E27 alarm engine is going to be based off of IP. So you're going to have your either your wireless or your wired connection. So we're utilizing Wi-Fi. You would use our adapter to add Wi-Fi to the panel, or you could plug it in directly with the onboard Ethernet port. And so these two forms of communication are going to be primarily what we're using. Is what we're going to depend on. I will state that you will need a form of communication to interact with the panel to configure it. So we use our mobile app. So the mobile app either needs IP communication or cellular communication in order to connect over to the system to configure it. You can use our new AEX cell. Either one of these, Verizon or AT&T, would allow you to connect over to the panel, and it connects up to the data bus is how it actually is connecting over there. So the last item that we have as far as communications goes is our DD module, our XDD. So that is a dialer module. Primarily it is used in the dial capture market. So if you're using a dial capture radio from one of the big cellular providers and you're wanting to have a backup to your IP, it's a great solution for that. So the AEXDD can be used for there, or if you do have a traditional POTS line somewhere you still want to use, it works for that as well. Alrighty, let's move on to the data bus. I'll talk a little bit about how the data bus is interacting. So when we talk about our 485 data bus, what we're referring to is the way that the expansion modules communicate over to the E27. So we have a visual representation of it here. So the data bus loads in here. You'll see it comes down. These are data bus expansion modules. And then you come down, and this is, imagine your data bus trunk line. So over the data bus, you can have all of these different devices can be tied in here. You can have up to 32 individual devices tied to the data bus. These devices are serial addressed in our legacy system. They were dip switch addressed. In the new system, they're done by serial number. So there's no more certain address positions, things of that nature. None of that has to be considered in the new system. It's automatically addressed when you do a discovery or a enrollment of the bus. So again, your expansion modules, your dialer modules, your cellular, your keypads, all of these things utilize the 485 bus for communicating over to the main E27 controller. Alrighty, so how all that fits together and how you expand the system. So again, I talked about your inputs first there. So if you're expanding more inputs, you would then utilize the 485 bus to tie that expansion module in, and that would give you an additional 16 inputs hardwired. Let's say you need to expand to a 345 wireless receiver. You could take one of our XRF modules, put it on the bus, use the RF3H module, and that'll give you the 345 megahertz. So you can tie these and expand, and that gives you the expansion into the wireless devices. Now, you can even have multiple wireless technologies within the same system. You have up to 4 receivers, technically 5, but we'll get into that in the future. But for now, we'll just say 4 for simplicity. And if you do your 4 wireless receivers, you can mix and match all of the different technologies here. So really that's basics of explaining, exactly how kind of all of this fits together. So the next thing that's not necessarily on this is we'll refer to ElkConnect. And when we refer to ElkConnect, ElkConnect is the platform we use for our mobile apps and our touchscreen application. So when you hear us refer to ElkConnect, it's either our mobile apps, our touchscreen, or it could also be our cloud in the web portal is ElkConnect as well. So that's the software you use to interface with the system. So again, hopefully this helps kind of a little bit of a glossary of terms and terminology to do a little visual explanation as to what these different things are. So as I mentioned, inputs, outputs, user interfaces, communications, and how the system expands is really what I wanted to cover in this short video. So if you have any questions or if you want to more elaborate on that, please reach out to us at our tech support team at ELK Products. And that concludes this video, and I look forward to talking to you in the next one. Have a great day. Thanks, everybody.